what can you say about programs that are put together by copying and pasting code from PHP for Dummies? Would it work?
Yeah.
Okay, but work has you can qualify, work. Okay, does this program work? Yes, it does. But then you can also qualify it by saying how well does it work. Okay. Now, what do you mean by how well does it work? Here's the program. Here's the web page. I type here something. I click a button. It does exactly what it's supposed to. Go ahead.
How much more to the bare minimum?
Okay. So what would be beyond the bare minimum?
What you want it to do?
Well, what about people who type in something that is incorrect, that is invalid?
Then it won't work.
Would it catch it? Okay, would it catch it and come back and tell the user, you're inputting something that is invalid, this is why it is invalid, and you should fix it? Go ahead.
So it'll work, but it'll probably be bloated and inefficient because you might get various different parts from various different programmers, and it won't necessarily follow. I mean, it'll follow the same logic, but it might be in different styles. So even though it works, you might be able to do it in a more efficient way.
If someone uses the copy and paste approach, yep, exactly. How about security? Now, you guys know that security is becoming more and more important, right? What does that have anything to do with what I'm talking about here? Yep, yes, sir.
People see the code and they know what you're using. It's like putting an alarm on a house. If you're the one who installed it, you know your password.
It's a little bit more than that. The code that they have in PHP and MySQL for Dummies is very unlikely that they will pay a lot of attention to security settings and security aspects. So without all that stuff, a hacker can read this book, okay, and figure out what would be security holes included in the sample code of a book like this, okay. And as a hacker, you cannot read the source code of a website. If you go onto mom and pop's grocery store website, you don't know exactly what is the PHP code behind the website. But if you have a suspicion that it is coming from, say, PHP and MySQL for Dummies, you can try tactics to attack that server. And if it does come from a book like this, then your tactic may work just the first time. Now, nobody is really, nobody cares about, mom and pop's grocery store's website. But how about bigger websites? Banks, okay? The IRS website, and so on and so forth. Now, if you put in, a MySQL code injection and website, or the web pages are not written correctly, you can actually end up pulling the entire database out of the database. Not just, a database, the data point of one single person, but you can actually pull, all the data points out of the entire database. So there goes the security, there goes privacy. Okay? But what does that have anything to do with this? It requires a lot of mathematics background to anticipate all of that, okay, for once. So there are two schools of thoughts here. One school which is led by Dijkstra. This is his last name. Dijkstra is a Dutch last name, I think. He suggests that programmers should be mathematicians first. And he wrote a book on this very subject. You can go to Wikipedia and search for the keywords cruelty computer science. And he basically says, someone has to be a math major first and then use computer science as a branch of mathematics. The other school has to do with Donald Knuth, and this guy is still around in Stanford. And he claims that with better tools, everyone can become programmers. Okay? So these are basically completely opposite thoughts. One is very rigorous and say that you have to be really good at math before you start to write the first line of program. The other one is saying, well, since we have all these cool tools, you can just go ahead and write programs. You don't need a lot of rigorous math background. So which one is right? What do you guys think?
I think there's a compromise between them.
Sorry?
There's a compromise between them.
It depends on what kind of program you're writing. Okay? It depends on the application of your program. Where is that program going into? Let's think about something that is relatively trivial, if it is broken into or if it is If it has bugs, it's not a big deal. Can anyone name programs like that? Yep, go ahead.
Simple like HTML. Hey, there's my name. Page.
Well, I can find plenty of examples on my phone. The Compass app, okay? If it has a bug and it does not report the direction, as accurately as it should, or it crashes, unless I'm really lost in the wild and I'm relying on that one app to find my way back, it's probably not going to be a big deal. Okay? What about programs that are really critical? If it goes bad or if it misbehaves in any way, lots of people will be affected. What about those systems?
Like internet.
How about the control system of a nuclear plant?
Well, that's who usually goes to. It's like
Well, that will take out, easily, with smaller states, half a state easily. Yeah.
At least.
Okay, so we are talking about different types of program here. Okay, some programs require, everything has to be working perfectly. And other types of programs, whatever, you can throw something together, it's not a big deal. Okay, so once again, that comes back to these two, schools of thought. One has to do with, okay, let's get everything done right. And the other one has to do with, we can throw something together and it will work for the most part. But whichever way you want to go depends on what kind of program you're writing. Are you writing an extension to a program that is already mostly written? Well, in that case, you cannot be introducing too much of a problem, even if your code is not perfect. On the other hand, if you're writing the operating system of the nuclear plant control system, then you better be very careful. Okay, are we okay so far with these top concepts? So what we are doing with this particular module is we're introducing some math here, so that instead of asking the question, will this program work for this test case? Will this program work for this test case? Will this program work for this test case? We're asking one single question. Does the behavior of this program match the expected outcome? If it does, we don't need a single test case. That's the objective. Do you guys still remember test cases? Remember that program that we wrote to find the maximum of two variables? How do we know that program is going to work for all values of x and y? Sorry?
You need a precondition.
You need?
We knew precondition.
Well, what did we do when we wrote that program? What did we do to kind of show that that program is correct? We have a few test cases, right? But how many test cases do you need to say that this program will work for the next test case? There's no need to test it anymore.
Until we find that it's true.
Until we find what is true. The variables? Well, in theory, you have to test for every single value. Okay, if the program takes a variable x and a variable y, you need to give it all combinations of x and y in order to check the result whether they are all correct or not. And that's going to be a lot of test cases, right? And this is a really simple program too. This is a really simple program. Its only purpose is to find the maximum of two variables. What about a program to find the maximum of three variables, which we also covered? That will take more test cases, right? So that's not really the way to go, because what if you miss something that you thought was obvious? In other words, of three variables, we can try. Here's my pen. Okay. Of three variables, w, x, and y, we can try like 2, 3, 1. We can try 3, 1, 2, and so on and so forth. What if you missed one? What if you missed 1, 2, and 3, and this is the test case that did not work because one of the comparison symbol is opposite or incorrect? Then the program is incorrect. Okay? So what we want to do is to use the concept of a precondition and a postcondition in order to prove that a program is correct. In other words, we are not poking the program and see whether it behaves correctly. We are proving, analytically speaking, step by step, that the program is in fact mathematically correct. That's what we want to do with this module. So we are walking away from traces for the time being and focus on the mathematics behind the behavior of a program. Is that okay? Okay. So what we want to do is to analyze the pre and the post condition of a program. The precondition of the entire program is what do we know about the variables before the program starts to execute. Do we know that W has to be greater than X? Do we know that X cannot be the same as Y? Because those assumptions can change what the program needs to do to give you the correct result. That's the precondition. The post-condition of the entire algorithm is a mathematical equation or Boolean expression or condition that describes the correct output of the entire program. Okay? So we started with the precondition. We know that these assumptions have to be true for the input of this program. And then we want to end with the post-condition, which states, if the output of the program meets these criteria, then we know that the program is working correctly. But in between, we have all these lines of pseudocode or real code or whatever that we have to go step by step and then say, can we go from step 1 to step 2? Can we go from step 2 to step 3? And every step along the way, you have to use mathematics to derive the post condition of the next one. Now, if we can do this, then there's no need to use test cases anymore, because a proof of the correctness in this case, using the pre and post conditions, will cover all possible test cases that can be thrown at the algorithm. Okay? So we'll come back to this slide when we get to that point. Now I can read my notes, or I can use an example. So I'll just go ahead and use an example to illustrate the concepts. We'll go ahead and start with something relatively easy. So we'll maximize the screen. We'll start with line 23. And line 23 has a single statement, assignment statement. X gets a value of 4. Okay, doesn't matter. Do we know what this statement does? It's an assignment statement. And X is going to be updated with a value of 4. So we already have done that many, many times. We know what this line does. But this time we'll introduce a precondition. For reasons that I cannot explain here, because it has to do with the 22 lines before line 23. Let's just say that by the time I get to line 23, I know this particular condition has to be true. In other words, in this case, I'm just randomly picking some conditions, and I say that by the time we get to line 23, we know that X has to be less than Y, and we also know that Y is different from Z, and that's it. Okay, this is the condition that I know before line 23 executes. Okay, and this is regardless of the precondition of all the other variables. By the time we get to line 23, it is guaranteed that X is less than Y and Y is different from Z. Is that okay? Is that concept okay? That a precondition is a guaranteed condition by the time we get to that line. Okay? In this case, it has to do with the 22 lines before line 23, so I'm not going to tell you exactly why pre-23 is this. I'm just telling you that it is. The question is, after line 23 executes, what can we guarantee? X will be 4. Very good. Which means X equals 4. What about X is less than Y? Can we keep that condition? Can we keep the relationship between X and Y, not knowing what Y is?
Right now. Yes.
No, we cannot.
Why?
Because this condition has to be true regardless of all the values of X and Y and Z. Okay? So what if Y was greater than X because Y had a value